Hello and welcome to episode 8 in the series. In the last video we added a bit of error handling to our compiler, and this time we're going to start getting things ready in order to generate our IL code. So one of the tools I found quite useful for working with IL code is a program called IL Spy, which is available in the Windows Store. And it's quite nice because what you can do is you can give it an existing .NET exe or DLL, such as our Hello World application, and it will now show you the IL code behind the scenes. So you've got a drop down here so you can see the original C# code, and then the corresponding IL code, or the IL code with comments saying this is the C# code it corresponds to. So for example, when we create a new array for our tape, these are the 3 IL statements we need to use. Now, one of the things to notice is, although we had loops, or in particular we had while loops in our C# code, you don't really have them in the IL code. Instead, everything's lowered down to use just labels and effectively goto or branch statements. So, for example, here we branch if a condition is false back to or forward to the instruction at 2f, which is down here in this case. So that's what we're going to do this time, because at the moment we've got while loops in our code, so we need to get rid of those and replace those with labels and goto statements. So the place we want to do that in our code is here. So we've passed our source code, we've gone through the optimization steps, we've checked for empty loops. So before we generate our C# code, and we'll have something similar for generating our IL code, we want to remove any loops and lower it into one flat structure. So we do a simple set of ideas before, where we pass in the existing block and we get a new block back. So it will be, so I'm going to call it lower, and we give it the original block. So our lower method. Right. So the way I like to code these things up is I always start off with the most simplest case. So we're going to create a new block, which is going to represent our entire program. So because it's a whole program, it's not going to have a parent, so we can leave that blank. And at the end of our method, we're going to return that new block. And then what we're going to add to the new block is all the instructions. So if our program had no loops at all, this would be as simple as add the existing instruction to our new block. However, we do have loops, so we need to cater for those separately. So we know we've got a loop because we've got an instruction which is a type block. So if it's a block, then we've got to do something else. Otherwise, we just add the instruction as before. So now we need to decide what it is we want to do when we see a loop. So currently our code looks like while, just get this exactly right, so it's that. Our code at the moment looks like that. So while our pointer is not 0, we do some stuff, and then we terminate our loop. And what we're going to change that to, so there's 2 ways around to doing this. You can either, you're always going to have a condition and a couple of labels, and you can either have the condition at the bottom or at the top of the loop. So I tend to write it at the top because it looks similar to our existing code. So we end up with a label at the top. Top of the loop will be our first label. Then I'm going to say if, so I'm going to invert the condition, if it equals 0, that means we don't need to do anything, so we're going to go to the end of loop. Otherwise we do some stuff as before. Then we go to the top of the loop, and then finally we have one more label, which is our end of loop label. So what we need to do is we need to emit 4 new statements, these 2 here, then the contents of our block, and then another 2 statements. So let's do that. So the first one we're going to add is a new label. And we're going to give the label its name. And we need to give it its name because we can have multiple loops and we can have loops nested inside a loop. So we can't just call the label simple top of loop. It'd have to be like top of loop 1 and end of loop. Oh, probably 1 as well. So each time we're going to supply a label number of some type. So then we've got our conditional jump statement. And we're going to be jumping to the end of the loop. Then we've got to do some stuff. So that means that we need to actually write out what we want to do. We need to write out all the instructions within that block. So we're doing the same sort of thing again. So this can be a recursive call to just this piece of code. So we can extract that to a local function. And call that lower block. So the block we're going to lower is our block, and the block we're going to add our instructions to is the new block again, because we only have 1 block. Now we can add a goto statement, or a jump as we're calling it. So we're going to jump back to the top of the loop. And then finally we need a label for the end of the loop. Okay, so now that's our basic structure, we just need to get it to compile. Right, so the first thing is we need this label number. And so we want the label number to be unique across all the loops in our code, even if they're nested inside each other and so on. So we need to keep track of that at a higher. We can either have it as a static sort of variable up here, or we can feed it down into each sort of recursive call by reference. It's going to be a lot easier just to keep it at the top. So next label number. So in here our label number is now the next label number, and we can increase the next label number by 1. And let's put the static. And we need to save this away. We can't just say next label number in here, because calling lower block may allocate new labels, in which case we'll end up with a different value for label number here as we had here. So this is a better way of doing that. So now we need to create 3 new instructions for label, conditional jump, and jump. So let's do label first, that's the easy one. So the constructor for label takes the name of the label and make that a property. And the C# we want to generate is just going to be the name of the label followed by a colon. So then we can do jump. Target. So this is the label we're going to jump to. So target label name. And finally conditional jump, which is going to be similar to this one. We're only going to do the jump if the value is 0. goto's got to have semicolons. Okay, so we've got a label, which is just the name of the label followed by a colon. The jump statement is just go to that label. Conditional jump, if the current value we're looking at in the tape is a 0, then we do the jump. That's fine. So that all compiles. So we write out the label, we write the conditional jump to go to the end of the loop. Otherwise we do whatever's in the loop and we go back to the beginning so we can check the condition again. That all looks okay. So our program is going to compile our hello world example. So let's run that. Okay, that's right. So let's find our file. So 5 o'clock, that's the right time, so have a look at what it's generated. So this is our, okay, so it's a nested loop, so let's look at that loop instead. So top of loop, if it's not, we jump to the end of the loop, otherwise we do the stuff in the loop and we loop back to the front. That looks okay, and now we try running the program. 5 o'clock, that's the right time. So it's still printing out the right thing, that looks good. And if we look at our program, we see we've got no while loops in here now. It's all using jump and goto statements. So that seems to be working. So we can move these files, these classes into their own files. Tidy things up. Try again. That's better. And the only other change is, so down here we're going to end up adding a new method, which will be generate my outcode. And one of the things we want to be able to do is support debugging. And in order to support debugging, we can't optimize our code, because if you imagine, you can't, once you're sticking through the code in the debugger, the actual code needs to match the source code. And so at the moment our optimization code actually combines some statements, so we'd end up with less code. However, we do need to do the optimization, because otherwise we can't do our code for checking for empty loops. So what I think we need to do is rename this to be optimized code, because we're always going to have to optimize it, and because that's the thing we're going to use for checking for empty loops. However, when we lower it, we either lower the optimized code or the original code, depending on whether or not we're debugging. So is this a release or a debug build? So eventually that will be another parameter, but for the moment we'll just hard code it. So we'll say release mode equals true, so we're going to optimize. So then down here we say what should we say? Release mode switch. So when we're in release mode, we lower the original code. When we're not in release mode, no, that's not right. When we're in release mode, we lower the optimized code. When we're in debug mode, so we're not in release mode, then we lower the original code. And maybe we should make it a bit clearer, rename that as well to be lowered code. So I think we're all ready for the next episode when we actually start generating the IL code.